This is a video for AQA Further Pure Mathematics. Vectors, section 3.4, intersection of two planes. This diagram shows that if we've got two planes that are non-parallel, now by non-parallel their normal vectors are not going to be the same as each other, so we have n1 is not the same as n2, then they will intersect along a line. And we'd like to find the equation of that line in the form r is equal to a plus lambda b. Remember where a is a point on the line and then b is a direction vector. So we've got point plus direction. Well, to find this, we want to see, is there a connection between all the points x, y, z which lie on this line that we can find from the two equations of the plane? Well, taking those equations as being equation 1 and equation 2, then the first step is to eliminate one of the variables. So the easiest one here is to eliminate x by doing equation 2 minus equation 1. And that gives us the fact that y plus 2z is equal to negative 3. And that must be true for all the points on the line. If we introduce a parameter now, so we can do that for either y or z, but let's take z is equal to some parameter lambda. And what we want to do is to then find expressions for x and y in terms of this new parameter that we've introduced, lambda. So we can see that y plus 2 lambda must be equal to negative 3, and therefore y is equal to negative 2 lambda minus 3. If we put those expressions into equation 1, then x plus y plus z, which is lambda, is equal to minus 1, and we can rearrange that to show that x is equal to 2 plus lambda. So let's just go through those steps once again. We started off with our two plane equations, and by eliminating one variable got an expression for y in terms of z, and by introducing a parameter lambda we could then from that calculate that y was minus 3 minus 2 lambda and x 2 plus lambda. So we've now got expressions for x, y and z in terms of lambda. If we now put those equations together, we can see that we have x, y, z is equal to, well, we've got the values without lambda in them, so x is 2, y negative 3, and z 0, and then lambda times 1, negative 2, and 1, and those are simply the coefficients of lambda, 1, negative 2, and 1. And that's then the equation of the line in the form that we wanted. We've got here a point, the vector for a point A, and direction. And if we look at the diagram here, A is the point 2, negative 3, 0, and this is the direction vector, 1, negative 2, 1. So in summary, the steps are as follows. We use the two equations that we've got for the plane to eliminate one of the variables. We can then choose either of the variables that remain and make it equal to lambda, which then gives us three equations, one for x, one for y, and one for z in terms of lambda. And then all we need to do is to write r is equal to x, y, z, so that will then be equal to a known point plus lambda times direction vector. That's the end of this video on intersection of planes, and indeed completes the series of videos on equations of planes.